Exam tip suggestion for you. Dear NPTEL learners, most of the questions come from assignments. In spite of your busy work, please revise once after watching the video to get better score. Hello viewers, in this video we will see the solution to assignment 1 for the course Analog Communication. First question, which of the following best describes an energy signal? The solution is, the definition of total energy is E equal to limit t tends to infinity, integration minus t to t, x of t magnitude square dt, joules. A signal is said to be an energy signal if and only if its total energy E is finite, that is E is less than infinity, greater than 0. So the answer is option A, a signal with finite energy over all time. Option A. Second question, energy signals must have finite duration to exhibit finite energy. The solution is, answer is yes, option A, true. Option A, true. Third one, if a discrete time signal x of n is a power signal, which of the following must be true? The solution is, definition of power of a signal, average power for a discrete time signal is given by P equal to limit n tends to infinity 1 by 2n plus 1 summation n equal to minus n to n x of n magnitude square. A signal is said to be a power signal if its average power P is finite, that is P is greater than 0 but less than infinity. So the answer is option C. Option C, limit n tends to infinity. Option C. Option C, limit n tends to infinity. This is the 1 divided by 2n plus 1 summation n equal to minus n to n x of n magnitude square is finite. Fourth question, if the Fourier series of the signal is given by x of t equal to a naught plus n equal to 1 infinity a n cos 2 pi n t by capital T plus summation n equal to 1 to infinity b n sin 2 pi n t capital T, and the modified exponential Fourier series of the same signal is given by x of t equal to n equal to minus infinity of course summation cn exponential minus 2 pi j n t by capital T, which of the following relation is true for n greater than 0? For n greater than 0. The solution for this is, answer option B, an equal to cn plus c minus n and bn equal to j cn minus c minus n for n greater than 0. So the answer is option B. Option B. Answer is option B. Fifth question, if the Fourier series of the signal is given by x of t equal to a naught plus summation n equal to 1 to infinity a n cos 2 pi n t by capital T plus summation n equal to 1 to infinity b n sin 2 pi n t by capital T for any half wave symmetric signal x of t, which of the following quantity is identically 0? The solution for this question is, for half wave symmetric signal, it can be shown that DC component, the coefficient a naught equal to 0 and only odd harmonics is present or exists. That is, for n even, a n equal to b n equal to 0. That means a2, a4, a6, a8 so on is 0, b2, b4, b6, b8 so on is equal to 0. So the answer is option C, A 2n, B 2n both, because A 2n is for n equal to 1, 2, 2, 3, 4 will get this one, B2n for n equal to 1, 2, 3, 4 will get B2, B4 so on. So the answer is So the answer is option B. Both. Sorry, option C. The answer is option C. Option C. Sixth question. Categorize the following signal as energy/power signal and find its value. The solution for this is, sixth question, given x of t equal to e power minus 2t, t greater than or equal to 0 and 0 otherwise. So by definition energy E equal to integration minus infinity to infinity x of t magnitude square dt, and this is 0 to infinity because t is greater than or equal to 0. So e power minus 2t magnitude square dt. So 0 to infinity e power, this becomes e power minus 4t, which is with respect to t, and this integration of this will be e power minus 4t by minus 4 and 0 to infinity. If you substitute for t infinity and 0 here, so what we will get is minus 1 by 4, 0 minus 1. So therefore E equal to 1 by 4. Since the energy E is finite, x of t is an energy signal. So the answer is option C. It is an energy signal with energy 1 by 4. Answer is option C. Energy. It is an energy signal with the energy 1 by 4. Seventh question. Which of the following statements is true about Dirac delta function? We will see the solution. The definition of Dirac delta function, delta t equal to 0 for t not equal to 0, and integration minus infinity to plus infinity delta t dt, it should be equal to 1. So the answer is option A. Option A, integration minus infinity to infinity delta t, integration with respect to t is equal to 1. Option A. Eighth question, find the power of the signal x of t equal to a cos omega 1 t plus theta 1 plus b cos omega 2 t plus theta 2. Assume omega 1 is not equal to omega 2. So solution for this eighth question. This is somewhat a lengthy solution. So consider p equal to limit t tends to infinity 1 by 2t integration minus t to t x of t magnitude square dt. Now if x of t equal to a cos omega 1 t plus theta 1, then p becomes p equal to limit t tends to infinity 1 by 2t integration minus t to t a cos omega 1 t plus theta 1 magnitude square with respect to t. So now using this formula, cos square theta equal to 1 plus 2 cos theta by 2. So this becomes 1 plus cos 2 omega 1 t plus 2 theta 1 by 2. So if you evaluate this, if you integrate this one, so you can integrate this power 1 with respect to t and integrate this with respect to t. So what we get here is p equal to a square by 2, and this second integral becomes 0 because integration of cosine function over full cycle is always 0. Okay. So similarly for the second term p equal to power p equal to b square by 2, and then for the given problem x of t equal to a cos omega 1 t plus theta 1 plus b cos omega 2 plus theta 2. So if you substitute x of t in this equation x of t, it is substituted here, and then you expand using the formula a plus b whole square formula, it becomes a square cos square, then b square cos square, and then 2ab cos omega 1 t plus theta 1 multiplied by cos omega 2 plus theta 2. And then for the first you can simplify. You can see here, this is the first term, this is the second term, and this is the third term, and this first term from equation 1 we got the answer a square by 2. For the second term we got the answer as b square by 2. For the third term what we can do is we can apply cos A into cos B formula. So cos of A plus B plus cos of A minus B whole divided by 2. So if you apply that formula here, so we will get this one, this equation. So for omega 1 is not equal to omega 2, you can see here the third and the fourth term becomes 0. The reason is integration of cosine function over full cycle is always 0. The third term, that is this, okay, becomes 0. Therefore the answer is P equal to A square by 2 plus B square by 2, that is equal to A square plus B square by 2. So the answer is option B, A square plus B square by 2. Answer option B, A square plus B square by 2. So ninth question, for the same signal given in question 8, find the power when omega 1 equal to omega 2. The solution for this is, so the continuation of the same problem. So from the problem 8 solution we got P equal to A square by 2 plus B square by 2 plus we had the third term, so as well as we have the fourth term. Okay, now third term and the fourth term. Now if omega 1 is equal to omega 2, so this the third term is 0 because cosine function, the reason is integration of cosine function over full cycle is always 0, therefore the third term is 0, and the fourth term, fourth term, so this is nothing but omega 1 and omega 2 is 0, therefore this becomes 0, this is 0. So therefore what we get here is AB limit t tends to infinity 1 by 2t integration minus t to t cos theta 1 minus theta 2 with respect to t. If you integrate this one, this becomes t, and if you substitute for t, minus t and t for t, we will get here the solution as for this part we will get AB cos theta 1 minus theta 2. So the answer is P equal to A square by 2 plus B square by 2 plus AB cos theta 1 minus theta 2. So this can be written as A square plus B square plus 2AB cos theta 1 minus theta 2 by 2. So the answer is option C, A square plus B square plus 2AB cos theta 1 minus theta 2 by 2. C, option C. We will move on to the last question, 10th question. What is the Fourier series representation of a square wave with a period t and amplitude a? So the answer for this is the square wave with amplitude a and time period is t, capital T. So x of t can be written as a for t 0 to capital T by 2 and minus a, it is t by 2 to capital T. This waveform has an odd symmetry because x of t equal to minus x of minus t, and therefore for this kind of odd symmetry an is always equal to 0 and a naught coefficient which is DC component is also 0. Now we only have to find Bn. So Bn equal to 4 by t integration 0 to t by 2 x of t sin n omega naught t dt. Omega naught is 2 by t, 4 by t 0 to capital T by 2 a sin omega n omega naught t dt. So this becomes 4a by t, integration of this becomes minus cos n omega naught t limit t by t to 0, and this is nothing but minus 4a n omega naught t, and if you substitute t by 2 and 0 we will get here n omega naught t by 2 cos of 0. Now because omega naught equal to 2 by t, so t cancels, 2 cancels, what we get here is cos n pi and cos 0 is minus 1, and then what we can do is 2a by n pi and this minus is taken inside the bracket, therefore this becomes 1 minus 1 whole power n. So therefore the coefficients Bn is equal to 4a pi n for n odd or odd n. So it is equal to 0 for even n, So therefore the Fourier series representation x of t equal to a naught plus summation n equal to 1 to infinity a n cos n omega naught plus bn sin n omega naught t. So these two are 0, therefore only we have this part sine term. So this is nothing, n equal to 1 odd, n equal to odd 1 3 5 so on, bn sin n omega naught t. This is equal to summation n equal to 1 3 5 7 so on 4a n pi sin n omega naught t. If you substitute omega naught equal to 2 pi by t here, x of t equal to 4a n pi sin 2 pi n t by capital T, n equal to of course 1 3 5 7 so on. So the answer is option A, f of t equal to summation n equal to 1 3 5 7 so on 4a n pi sin 2 pi n t by capital T. Answer is option A. So submit. Control end.